Hello friends, once again welcome back for this video shoot. Over here I am today going to discuss some sort of physics, because from last so many classes I am just discussing something which is you can say a phenomena of a natural incidents that I am observing and sharing with all of you intellectual people. So today I decided, let's talk something that is purely from physics. Now why I am saying so? Reason being, once with simple approach we learned few details, few topics by just observing into nature. I think as a student of science background, it's also your responsibility to apply that understanding, concepts or knowledge in some, you can say practical situations, like some examples, like some illustrations. So today's class I am going to discuss something that is purely from physics, but before that I would like to illustrate one very good situation, or you can say one example, so that you can get much better understanding of the phenomena of refraction through curved surfaces. Fine. Basically in today's class I plan to elaborate you chromatic aberration. Fine. So I will discuss chromatic aberration. Actually this is something which is associated with a lens. Fine. Associated with lens. Fine. Associated with lens. Now please try to understand one simple thing over here. Lens either concave or convex, but it is curved. Fine. Either this way, that is biconvex rather, and either this way, biconcave. Ultimately both have curved surface. So this curved term initiated an idea in my mind, that because I in depth explained you the phenomena of refraction through curved surfaces, and what I am planning to discuss today, that is chromatic aberration, which is associated with lenses. So rather than starting this discussion directly chromatic aberration, let's illustrate one good example of refraction through curved surfaces, because this is just a part of that. That way you can say I am somehow trying to force you to go back to take a look of those concepts. Fine. That I explained you with the heading like refraction through curved surfaces. So because we are discussing a problem, you can say a situation, that is you can say a drawback associated with the lens, and lens has curved surface. So just as an illustration I would like to explain you a simple situation. Fine. Then obviously I will come on to chromatic aberration. So what exactly this idea that I would like to share with you? Fine. So over here illustration of refraction at curved surface. Fine. Once again I am justifying this explanation. Curved surface means chromatic aberration, which is actual today's topic, is associated with lenses, and lenses are nothing but curved surfaces. So that is why I thought just to explain this curved surface process. Let us say I have two glass rods. Fine. 2 let us say over here mention 2 glass rods, let us say I have, fine, and they are arranged in this fashion: rod S1, rod S2, say for example S2, fine. Now, let us say this is the principal axis, 2 glass rods S1, S2, S1, S2. Mu is equal to 1.5, general value of refractive index for glass. Then let us say they are separated by a distance d. Listen carefully, it is a illustration, it is a situation. So, rather than writing down the language, I am writing some important terms and then I am explaining you these terms. Now, what is performed? This S1, in S1 a point source P, point source, light source has been placed, and let us say this gapping is 50 centimeter. Okay. So, once again listen the situation: 2 glass rods S1 and S2, refractive index 1.5, they are separated by a distance d, a light source P placed inside rod S, in this rod S, and the distance from this point to this point is 50 centimeter. Actually, why I picked this illustration? When I explained, just to go back to my previous videos, when I explained you refraction at curved surfaces, then I use this type of structure. I basically cut out this portion from a solid sphere. Okay. Now, because of this arrangement, listen carefully, the rays from P are parallel to the axis in S2. If the rays coming from source P are parallel to the axis in S2, find the distance d. So, I think I should write down this statement so that it is going to be easier for you to understand. What is that statement? 2 glass rods S1, S2. Now, I will use that space to write down the statement of requirement. Now, statement is, let light source point light source P placed in S1, and if rays are parallel, the symbolic representation, parallel in axis in S2, then find D. Actually, this question has been asked in prestigious IIT JEE entrance exam. Normal assumption in your mind is that IIT JEE exam questions are damn difficult. This question paper and this examination pattern is very difficult, while the truth is just opposite. This exam is simplest one. Number one, I will defend my statement. IT JEE, either mains or advanced exam, is a very simple exam which just checks your conceptual clarity of the topics and your ability to apply them, first thing. And this exam also checks the in-depth understanding, means your analytical abilities. So this is the simplest and a type of exam which you can enjoy. Cracking IT JEE and scoring a good rank is a simple thing. Passing out from any IITs with flying colors, that is difficult. But if you are focused, committed and love to analyze situations, specifically in physics, if your approach is from basics, no one can stop you cracking this exam. My only point is, this is something which is directly based upon the result, or you can say the approach with which you can understand the refraction through curved surfaces. So they love to check your conceptual clarity, basic understanding and ability to apply these aspects in various numericals. Fine. So now let light source P placed in S1 and if rays are parallel in axis S2, then find D. Listen carefully. Actually what will happen? If you place this light source either here or here, it may possible all light rays emitting out from this in S1 may not be parallel to S2. This is a specific situation when these rays are going to be parallel. So ultimately you have to find this distance D. Now during the, over here I would like to write down at this place, during the discussion of this topic, I simply used a Gaussian relation. What was that Gaussian relation? That I would like to mention. I will say, using Gaussian formula. And what was the Gaussian formula? That was mu2 upon V, mu2 upon V minus mu1 upon U is equal to mu2 minus mu1 upon R. This result we explained. Fine. Now let's say R is equal to 10 centimeter. This is something which is given in the problem. I specifically picked this illustration just to prove that IIT JEE exam, if you are a regular committed student, is the simplest exam to crack. Now over here, please try to understand the terms which I am going to explain. Fine. One is mu2 upon V, mu1 upon U, mu2 minus mu1 upon R. All these terms I derived in one of my previous videos. Now listen carefully. We have to apply this Gaussian formula twice. Listen carefully. We have to apply this Gaussian formula twice. Why? Once for S1, next time for S2. Fine. So when we apply this formula for S1, then what will be the final result, or just by putting the value? So you can say 1 upon V. Why I am saying 1? Please take a look over here. Because mu2 is something which is the refractive index of this surrounding in which these glass rods are placed, and that is nothing but air. Now over here it is going to be minus 1.5 given in the problem, minus 50. Why minus 50? Because the situation of the object is 50 centimeters is equal to 1.5 minus 1 over R. R means 10 centimeters. Simply solve it. See the simplicity of the problem. Simply solve it. You will get V is equal to 50 centimeter. Because I am using these relations for rod S1, so I simply say it's going to be V1. Now again apply the same Gaussian formula for S2. Fine. Again apply the same Gaussian formula for S2. So, what I am going to do? I am going to erase out this much portion, will only allow this much to explain you. Now, listen carefully. Same Gaussian formula we will apply. Fine. So, it's like that first half for which I calculated, I removed out. Now, only this much portion is something at which we should put our focus. Okay. So, again using the Gaussian formula, again by using Gaussian formula, result, formula, outcome, something like that. What you can get over here? You can say 1.5 refractive index upon infinity, because this image is going to form at infinity. Reason being, all these rays are parallel to the axis. So, the parallel axis, these parallel rays parallel with the principal axis, they will form the images at infinity. Fine. Minus now refractive index of the outside medium, that is 1 upon d minus 50 minus with minus sign is equal to 1.5 minus 1 is equal to 1.5 minus 1 upon 10 is equal to 1.5 minus 1 upon 10. Now, once you solve it, you will get it as V2 is equal to infinity I used. Once you solved it, what you will get? You will get D is equal to 70 centimeters. See the basic approach of this problem. They just simply asked whether you know this basic result or not, you can apply or not, and your ability. See, in one problem they checked your 5 concepts of ray optics: sign convention, remembering, the ability to retain some important results, then a situation in which you can apply these results. Fine. So, therefore, do not say that IIT JEE exam is one difficult exam, it is the simplest exam. Fine. Provided how much committed you are to attain the perfection. If your approach is casual, if you are reading things with just casual approach of like solving problems just by quick putting the values and these things, then you are going to suffer a lot. And if you are stick with your basic approach, no problem. Now, let us come back again, and this topic, chromatic aberration. Fine. Now, what exactly this concept is? I should say it is the inability of lens, defect of lens. Fine. So, listen, defect, although it is not a very good word, but it is like that, defect or inability of lens, defect or, I think I should write it down, defect or inability of lens to create image of a white colored illuminated point object as point. What does it mean? defect or inability of lens to create image of a white colored illuminating means white light illuminated point object as point. What exactly the phenomena? Listen carefully. Actually, let us say I have a convex or concave lens. So, let us say it is a convex lens. As an example I picked, okay. Now, let us say a point object is placed over here, fine. So, obviously, one ray will pass through the axis undeviated, another ray will pass from here, another ray will pass from here, fine. If it is white light illuminated object, so white light is not monochromatic light, it is combination of many wavelengths, many colors, fine. What will happen? Actually, this lens will produce the image in this side not as point object, but extended and blurred and colored. Reason I am coming on, but this is like this, fine, this way. It is a point object, but image you can see in this fashion. So, you can say a point object illuminated by white light, image is colored and blurred. Blurred means, see the gapping, I mean the width of the image, while the object was of point object. Colored, blurred means rather than clean point object, it is going to be longest one. So, image of a point object illuminated by white light created using a lens is always going to be colored and blurred. Now, it comes why it happens, what exactly the cause of this phenomena. Okay. So, first listen carefully the story. Actually, is it possible for you to assume that a lens either concave or convex is created using small lenses? Fine. First listen, then point by point I will write down. Now, white light means 7 colors. 7 colors means in vacuum the speed of entire this 7 color combination is same, but moment it will enter in the medium of this lens material. So, refractive index is something which depends upon wavelength, fine. So, the velocity of each and every color is not going to be same. The velocity of the color which has more will pass through first, lesser one with second and so on. So, every color will create the image in that fashion, fine. So, now please try to understand. Lens enable to focus different, and I will use red and blue chalk to show you some diagrams, different colored image, different color image as similar as same as they are. Why? Fine, a question comes, why so? Now, during the discussion of lens maker's formula, I mentioned 1 upon f is equal to mu minus 1 upon r1 minus plus 1 upon r2. Radius of curvature of both sides of concave or convex lens, refractive index and focal length. as mu depends upon lambda. I am not using some other complicated terms, simply I said lambda. Try to recall Cauchy's formula, 1 plus beta upon lambda square and so on and so forth. So, as mu depends upon lambda, so every color will focus. Who will focus? Lens will focus at different places, at different points. So, reason I hope now is clear to all of you, because focal length is something which is not same for each and every color. Reason being, the mu is something which depends upon wavelength as Cauchy's formula that we discussed. So, because of this reason, aberration is something which comes in the images formed by a lens. So, all these things. Now, one sentence I would like to mention over here, that aberration depends. You just keep on looking on my this chalk holder, the way I am explaining. Aberration depends upon, that is, aberration is something that depends upon dispersion of lens. Now, I thought it is better to show you the situation with the help of certain diagrams. Fine. And what are those diagrams that I will show you? So, let us first start the discussion using a convex lens. Fine. Let us say this is a point object placed over here. Fine. Now, let me allow to use different color chalks. I think I should make it more simple rather than complicated. Now, just take a look. One ray, this is see my simple approach. I hope now this is going to be more simple. White light, fine. Now, we have to use two different colors. From here, this ray will not come out at white light. Reason being, it will be bifurcated, truncated. So, one ray will come over here, fine, this way, and this is exactly going to be blue color, the way I am showing this blue color. Next, I am going to show you with the second color, which is going to be red color, fine. So, now imagine the situation, this is one point, this is one point. So, now you are getting an image where red color outward focusing, blue color inward focusing. So, this is something which is true for what? True for convex lens.